Okay, this is Mr. Bloom, and we are doing problems 24 to the end in our review. One more problem on 5.4, and then we're going to do 5.6 and 5.7. So at 24, we're looking at this idea that P is the centroid of triangle MNO. Centroid is made by medians, go from the midpoint to the vertex, okay? Now, this is a 1/3, 2/3 prospect, all right, when we're working with this. And that's the same here and here, 1/3, 2/3. So we are asked to talk about MP. And MP is this distance right here. That's MP. Now, write an expression to represent PR in MR. Well, MP is the two-part, okay, because it goes from the vertex to the centroid. So take half of 14x plus 8, and that's going to be 7x plus 4 and plus 4y because it's 8y. So that's my half part. So I know that that's PR. PR is equal to 7x plus 4y. 4y, Mr. Bloom. So when I'm doing this, I want to make sure I'm careful about it. So I go from the two part to the one part. But now the two part and the one part should be added together. So that'll help me find what my distance is from M to R is. So MR is really MP, my MP plus my PR. And MP, okay, is 14x plus 8y. PR is actually 7x plus 4y. Okay, so 21x plus 12y is my total. Okay, and that's where I'm at, 21x plus 12y. So when I'm doing that, that's my value from MR. So those are the two values they asked me to find. I know that MR is that, and I've got my PR, and I'm set. Now, on my next one, they're asking me, with coordinate geometry, find the orthocenter. Okay, so I've got my orthocenter set up. So I'm looking at my orthocenter. I'm going to get 2, 0, 2, 0. That's my A. I got 2, 4, 2, 1, 2, 3, 4, and 6, 0, 3, 4, 5, 6, 0, and that's my C. So I've got A, I've got B, and I've got C. Keep in mind, orthocenter is where my right angles come together, my vertices. Now, in a right triangle, the orthocenter is at the vertex of the right angle. So the vertex of the right angle, remember, in a right triangle, the orthocenter is the vertex of the right angle. Okay, so the vertex of the right angle is point A, 2, 0. All right, so let's move on. Now, this next one I'm asked, can a triangle have sides with a given length? Remember, if the triangle has sides of given lengths, if it's going to be a triangle, the two smallest sides must add together to be bigger than the largest side. So, can 2 plus 3 be bigger than 5? And that's not true. So this is not true. So not a triangle. Okay, same idea. The two smallest sides is where it's going to fail. So the two smallest sides is 9 and 11. Is 9 plus 11 greater than 15? And that is true. Yes. So it is a triangle. Same idea in 28. Two smallest sides, 17, 8 plus 9, that's 17. Is that greater than 18? This is not true. So not a triangle. Now, in 29, 30, and 31, I've got to take my calculator out and figure out what my values are that are missing. Remember, total interior angle value of a triangle is 180. So I have 57 degrees here for my angle N, and I have, 67 for my angle B. and I have 44 for my angle D. So I was able to find those with my calculator because the total interior angle value of a triangle is 180 degrees. Now they're asking me to list the sides of the triangle in order from shortest to longest. Well, this idea is set up using hinge theorem, and inside a triangle I have the angles provided, and I can determine relative size of the sides, okay, based on the angle across from them. The smallest angle, 44, is across from RN. So the RN is my smallest side. Okay, side RN is the smallest. My next smallest is RS. And then the largest side is NS. So small. This is small, because they asked me the shortest, the longest, and this is my longest. There. Now, I'm going to do the same thing in 30. Okay, well, JB is the shortest side. On that's JB, it's opposite 53. PB is my next size side, and JP is the next one. So that's my order from short to long. Okay, and in 31, I have 44 is opposite MQ. Then I have QD, and then I have MD. Okay, short to long based on the values here. This is 44, that's 46, that's 90. Okay, now they're going to do this to me without a sketch. So keeping in mind that I'm looking at a triangle, if I wanted the sketch, I could totally go PQR and put that 55 is inside Q, 82, and R is 43. But I kind of like doing it this way. This way I'm going to show you that this is the shortest angle. And the two letters that aren't being used is PQ. So PQ must be the shortest side. It's opposite the shortest angle. So the shortest angle is R. That's right here. And PQ is the shortest side. Now, if I'm looking at 55, 55 is the next largest angle, and it's opposite PR. And you got to keep in mind that's P, and angle P is 55, and that's QR. So QR is my next size. And my last one is going to be PR, because that is opposite the largest angle, okay, from short to long. Okay, now list the angles of the triangle in order from smallest to largest. Well, the angle that's largest is opposite the largest side. So, and the angle that's smallest is opposite the smallest side. So this is my smallest side, NS, and NS is opposite angle M. Okay, MN is opposite angle S, and my largest angle is opposite MS, which is angle N. Now, that's what I said based on the information provided here, the letter that's not there. But if I do it this way, if I go M, N, and S, MN is 7, NS is 5, MS is 9, I can determine that the largest angle is 9, and the smallest angle is M, and the middle angle is 7. So, S, so we got that down. Now, two sides of a triangle have side lengths 8 units and 16 units. Describe the lengths X that are the possible third side. Well, the possible third side is going to be 17 minus 8 and 17 plus 8. Okay, really comes down to that, the difference in the sum. So I'm going to have 9 and 25. So the range for my possible sizes is 9 to 25. Now, the very last page of this, we're asked to determine which is bigger, AC or XZ. XZ is opposite 101, and this is side angle inequality because the sides are the same. So it's this angle, and then we're looking at AC. And AC is across from 75, XZ is across from 101, and XZ is bigger. Okay. Here in 36, they're talking about, hey, can you determine DF and FG? Well, with this being the same, okay, and this being the same, they're wondering what's going on here with this angle. And they're wondering about DF, and this is DF, and this is FG. And I don't have any information about these, so there's not enough info. No conclusions possible here. No conclusion. I just don't have enough to make a determination. If I had a little bit more information, perhaps, but right now, I do not. Now, finding the range of possible values for each variable. Okay, now in 37, I've got this is 17, this is 17, this is 13, that's 13. So those angles are all set. Okay, so I know 45 is opposite 12, and 5x minus 10 is opposite 18. So we're saying that 5x minus 10 is much bigger than 45. But that 5x minus 10 can't be any bigger than 180. So that's my relationship I got to set up. And I got 55 is less than 5x, which is less than 190. And I divide by 5, and I get 11 is equal to x, which is equal to 38. So that's my range of values right there. It's 11 is less than x, which is less than 38. Now I set up the next one in a similar fashion. I look at these values, 6 and 9, and let me change colors. I'm looking at the values 6 and 9. 6 is smaller, so I know 3x minus 7 is smaller than 30, but I know that must be bigger than 0. I do the same thing. I add 7, 37, divide by 3, I got 7 thirds. It's less than x, which is less than 37 thirds. And that is my possible range for that. Now, in 39, 40, and 41, let me get these a little scrunched down a little bit. Let's move those up so I can see my diagram. They're asking me here to determine what's going on. Copy and complete with greater than or less than. Explain your reasoning. So the measure of AEB. AEB and the measure of EBD. I'm just going to talk about EBD here. Now, those things held the same. EBD is across from 23. And AEB is across from 21. Since EBD is across from 23, EBD must be greater. Okay, so EBD is across from 23. So angle EBD is greater. Now, when I do this next one, segment AB, what is that compared to segment BC? Now this is BC. Now remember, these things are still held the same, and I've got this blue going across here, and this is 59, and this is 79. 59 is smaller than 79, so BC must be smaller, because BC is across from 59, and AB is across from 21. Now they ask here, in this last one, 41, segment BC, which is across from 59, okay, and segment ED, which is across, okay, so this is 59 degrees, okay, but keep in mind that EBD was across from a 23 segment, AEB was across from a 21 segment, and AEB was 79 degrees, okay, and we determined, and the reason why I'm bringing those back in is that EBD is across from 23, and that's ED, okay, and EBD was larger than 79, so this was across, and we determined that EBD is a larger than 79 degree angle, and so if I'm looking at angle or segment BC, and segment BC is across from a 59 degree angle, then I'm really talking about the fact that ED's got to be greater than BC, because ED is across from an angle that's bigger than 79 degrees. Okay, so that's what we've got for our solutions here. Hopefully those made sense, and I hope you guys are doing well for your prep for your test. But again, if you have any questions, find your local geometry teacher and ask them. Have a great day.